All right, guys. So we're back. So as I was saying, in finding the class midpoint, which is halfway between the class, all of the classes, if they are uniform, if they all have the same class separation in terms, if the numbers that separating them are the same for all of them, all you can do, instead of adding them and then dividing by 2, the easier way you could do is find the difference between one of the classes. We found the difference to be 4. Then you divide the difference by 2. And then all we need to do to get all of the class midpoint is the lower values, the lower limits. We just add 2 to those. So if we add 2 to the first class lower value, the lower limit, we get 152. So what would be the midpoint now of the second class, Mr. Paisley? That's what I was asking.
75.5.
75.5. How would you get 75.5? I don't understand. Look at it again, Mr. Paisley, and think about what I just said. If you're adding 2 to the lower values or the lower limits of the class, and you add 2 to 150, you get 152. For the other class, which is the second class, what would be the class midpoint? All you do, you're adding the same 2 in all cases, you know.
234.5, sir.
Oh, you get 34. I don't understand. Which number you adding it to? What's the value of the second class? The limit of the second class, you have 155 and you have 159. And you're adding 2 to the lower one, which is you're adding 2 to 155. What you get?
$157 when me add 2 to 155.
So
must add 2 to 159 too?
No, you're not adding to both of them. I said add it to the lower limit. The lower limit is a smaller number.
I get a midpoint when you add 2 to a smaller limit, sir.
That's what I'm saying, Mr. Paisley.
Oh.
So you get it?
Yes, sir.
All right. All right, moving along. So any questions? Now the boundaries, you do the same way. The boundaries, you would add both of them same way and then divide by 2. But the easier way is to find the difference. What is the difference? What's the difference between the boundary values? This way, some.
1.
All right, thanks, Mr. Paisley. The difference would be 1. What would now be if you are dividing the 1?
Sir, I will just find a while ago. 1.
If you're dividing the 1 by 2, what you get?
0.5.
Right. All right.
Sir, that I answer to.
The difference between two of the classes. You see, when you have the upper class for one, the upper limit for one class, and you look at it, the difference between the upper class limit of one class with the lower class limit of the other class, the difference between them. Take away 154 from 155. You see the difference is 1. You see that?
Yes, sir.
Right, so that is the one that we're referring to. You look at the difference. All of them, if you look at them, the difference between them is just one. Isn't that the case? Is that the case, Mr. Paisley?
Yes, sir.
Isn't the difference between all of the classes upper class of one and lower class of the other? Isn't the difference one?
Yes, sir.
All right. So all I'm saying here, just as
Sir.
do the class midpoint, you divide the difference with the 1 by 2 and you get 0.5. Follow what I'm saying?
Sir, so when you minus them there, and that give you a class midpoint.
No, we passed this a long time. We're now looking at boundaries.
So that give lower class boundary when you minus first class from the second class.
No, the one does not give you the class boundary. Remember, each class has 2 boundaries based on the 2 limits. You follow? Look at this. Look at this. You're looking at the two diagonal circles that I mean.
Yes, sir.
All right. Now, when we say class boundary, you know, we are talking about a value that separates each class from the other class. So for the first class and the second class, which value would separate them?
1.
The difference between the limits would give you 1, but the value that separates them would be what? Let's weigh some.
Sir, could you repeat, please?
Let's weigh some. You sound very distracted. You know. What have you been doing, Miss? Miss Clark, help.
Headache.
Miss Clark, can you help us, please?
No, sir. So you start confusing me now, honestly.
Sir, repeat the question, please. It's just that I'm having a headache.
All right, let me take it a little slowly for you guys. Let me go back to where everybody understand the class midpoint?
Yes, sir.
So, Mr. Paisley, Mr. Luck, everybody in the raise.
Yes, sir.
All right. Do you understand this formula for the boundary?
Yes, sir.
Yes, sir.
All right. So, based on that formula, what are you supposed to do when you're finding the boundaries? Let's weigh some.
Sir, it all depends on which boundary you're finding, sir.
So give me a general statement of how you find the boundaries.
So for instance, sir, if we're finding the upper boundary, sir, we would add the upper limit of the class with the lower limit of the next boundary, sir, and then divide it by 2.
Miss Waysome, you're mixing up. You're not adding any boundary because you don't know the boundary yet.
That is what I'm saying, sir.
You're adding the limits. You're adding the one class with the lower limit of the other class and then divide it by 2. That's what you're doing.
Okay, sir.
Is that clear to everyone? Let me see your hands. You understand now, Miss Clark?
Yes, sir, I understand.
Right. So all I'm saying, instead of doing it this way, by adding them and divide by 2, you could just find what? The difference between the upper class limit of one class with the other one. The difference. So you take away the smaller value from the larger value, what you get?
1, sir.
1. You take away from this class up here, the 149 from the 150, what's the difference?
1.
If you take away 169 from 160, what's the difference?
1, sir.
So is it clear that all the classes have a difference with their upper and lower limit to the next by 1? Is that clear?
Yes, sir.
Right. So all I'm saying now, to get the class boundaries, you divide the 1 by 2 and you get what?
0.5.
0.5. Now, which values you're going to add the 0.5 to now to get the boundaries?
Sir, you're going, which class are you talking about, sir?
For any of the classes. Which
To
of,
the lower class bound,
which of the limit you'd add it to?
to the lower limit, sir.
Let's way some, are you in agreement?
No, hold on. Let me think about
Sir,
it.
I'm not sure if I understand what Miss Clark is saying really, but I know you would add the 0.5 to this. Sir?
Yeah, tell me what you understand.
The 0.5 would be added to the second limit of the class that you're working with, and then the next 0.5 would be added to the following class limit of the first class limit of the next one.
All right.
The one.
So if you're finding the limits, right, between the boundary between 149 and 150, right?
Yes, sir.
Difference between them is 1, right?
Mm-hmm.
And when you divide it by 2, you get 0.5, right?
Yes, sir.
Which are these values you would add it to?
You would get 149.5.
Right. Same 0.5. Which of these values you would add it to get the
154.5, sir. Said would always be added to the
which of
second
these
limit.
you would add it to get the boundary?
Second limit, sir.
Is that clear, guys?
59.
Is it clear that in order to get a boundary, you just find the difference between them and then you add it to what? All of the values in the upper class limits. Is that clear? So for you to get all of the boundary values, the same 0.5, you add it to each of these. So all of the boundary values would be what? This one would be 149.5. The next one would be 154.5. The other one would be 159.5. Next one would be 164.5. Do you understand how you get the boundary values? Let me see your hands. Right. Now, how is it different when we are dealing with the class midpoint? If we add it to which one of the values? Which one are the limits?
You add it to the lower one, sir.
The low, add it to the lower one. Is that clear, guys? So when you're finding the limits, when you divide the difference by 2, you add it to these when you're finding the midpoints. But when you're finding the boundaries and you find the difference between the diagonals, you add it to all of those on the right. Hope that is very clear to you guys. Is it clear? Raise your hand. You're all.
So can you repeat that, please?
Sir,
What exactly do you want me to repeat, Mr. Shamar?
You said something about on the right.
Yeah, it's just what I was saying. When you're finding the boundary values, you add the 0.5 to all of the values are the limits. on the right, which is all of the upper limits.
Oh, yes, sir.
Were you following?
Yes, sir, I was following, but
Yeah, man, that's what
apparently
we're saying.
struggling.
So I'm just saying that if you're finding the midpoint, when you find the difference and divide by 2, you add it to the limits on the left, which is the lower limits. But when you're doing the boundary values and you find the difference between the diagonals, you add the difference after divided by 2 to all those on the right to get the boundary values. That's all I was saying, Mr. Campbell. You get it now?
Yes, sir.
All right. Moving along. All right, so we know about class midpoint, we know about class boundary, we know about class width now. How do we find the class width again, Ms. Waysam?
Sir, we minus both boundaries, sir.
Ms. Waysam, I would like you to be more specific, Miss, because you always tend to not specify. You need to specify exactly what is happening. I don't want you to say about both boundaries. Specify it clearer than that, Miss. How it works.
Sir, you would minus both boundary from that class, sir. So minus the smaller boundary from the larger boundary of the class, sir.
I'm not sure that you understand what this is saying here, Ms. Waysam, because you're not minusing any boundary from any class. You're minusing the lower boundary from the upper boundary of that class. So for a particular class, you minus the lower boundary of that class from the upper boundary of that class. Is that clear, Ms. Waysam?
Yes, sir. For the midpoint.
Not for the midpoint.
For the width.
Yes, Ms. Waysam.
So, sir, this upper class boundary and the lower class boundary, is it not from the same class? So, for instance, you're looking at the second class, you have 154 and 159, sir. Now, the same one, you'd have to take away the 154 from the 159. Would it be like that?
Wrong, yes,
yeah. So, for instance, you have 155 and 159, sir. To find the class width, sir, you take 155 from 159.
No, you take 149.5 from 154.5. It's a boundary values, you know. Remember that the boundary values don't have anything to do with the left values. Only the values.
All right, and that, okay.
You follow? So the
yes.
value look at the first class, the lower boundary value, 49.5. The same first class, the upper boundary value would be 154.5.
Yes, sir.
You're taking the 149 from the 154.5 to get the one class width. Now with this upper class boundary for the first class, the upper class boundary for the first class becomes now the lower class boundary for the second class. The same upper class boundary that we have for the first class, which is the 154.5. This boundary is the same boundary for the lower class, the second class, lower class boundary. You seeing that, guys? So what is the upper class boundary for one class become the lower class boundary for the next class? This, let us add 0.5 to this. Because apparently you are a little lost with what I'm saying. All right. Look at all of these now. Tell me the boundary values that we have. Ms. Clark, tell us all the boundary values.
149.5, 154.5, 159.5, and 164.5.
All right. Now the 154.5, it is a boundary value, right?
Yes, sir.
Which class it's a boundary value for?
The first class,
Right. Is it upper or lower boundary value?
upper.
Upper.
Yes, sir.
We are saying that this boundary value, which is upper for the first class,
Yes, sir. It's gonna be the lower one.
boundary
the second
value.
one.
So for the second class, the 154.5 is the lower boundary.
Yes, sir. Understand that. sir.
That's all we are saying. The lower boundary value for this class would be what? 149.5.
0.5, sir. Yes.
Right? So even though this is the upper boundary for this class, it is also the lower boundary for this
For the
class.
first class.
Right. So when we are finding the class midpoint, we're really taking away the lower boundary for that class from the upper boundary of that class. Is it clear now, guys? What's happening? Ms. Waysome, are you clear?
Yes, sir.
All right. I'm not hearing anything from Ms. Tulloch. Ms. Tulloch, is your mic on mute? Or your mic cannot work or something?
Yes, sir.
Or is it that you're avoiding me?
Sir.
You know, you didn't talk much on Tuesday either, so I'm not sure what is happening. Are you just there listening to me, beating up my gum?
Sir, I'm just trying to understand what you're saying.
Just trying to follow me. All right, fair enough. All right, so are we okay with these now? All right, so I'm going to be moving on. I think I've labored that really a lot. So with that said now, in terms of these classes, this question is asking you to state the lower and upper boundary for the second class interval in the table. Calculate also the class width. Now, I think now, guys, with all that have been said about class width and class boundary, this should be easy for you to do. It should be. So let me hear, do the calculations and tell me what is the lower and upper boundary for the second class. And so this is the class that they want you to give us that for. So this is the second class. What is the lower boundary and what is the upper boundary? Please do that calculation. And then now you calculate the width of the class. All right, so go ahead. You have about 2 minutes to do that. Please go ahead and do that and give me the answers. Mr. Campbell, you want to tell us what you get for the boundary of the second class, the lower and upper boundary?
For the lower class boundary for the second class, I got 449.5.
What's the upper class boundary?
Let me work on also.
What class boundary, Mr. Isom, for the second class?
So you said the lower or the upper?
The upper class.
That is 499.5, sir.
All right. What is the class with Ms. Isom?
The class width would have been 50, sir.
Clark. Ms. Clark,
Yes, sir.
tell us how you calculate the class width, please.
Sir, you're going to subtract the 499.5 from the 449.5 from 499.5 and get the 50, sir.
All right, thanks very much. All right, so everybody, did you all arrive at the same answer for the upper and lower boundary of the second class, as well as the class width? Let me see your hands. All right, Ms. Tulloch, did you arrive at the same answer? All right, I'm not sure if Ms. Tulloch arrived at the same answer because she's not saying much. All right, moving along. So the solution would be you add, I mean, if you are to go this route, you would add upper limit of one class with lower limit of the next divided by 2. So upper limit of the first class times the lower limit of the second class divided by 2. You would get the lower class boundary for the second class. And then now you add the upper limit of the second class with the lower limit of the third class divided by 2, you will get the upper boundary. And then now you find the difference, and the class width would be 50. All right. We started looking at continuous and discrete variable from the previous class. Ms. Clark, can you just remind us what you learned about continuous variables?
Sir, I can give an example, sir. Like the continuous variable, sir, is basically like on a ruler, sir, you will have the sir, I don't know how to explain myself. Alright, so like on a ruler, you will have like 5, 8, 6, 8 go right up to 2, sir. And then like with the discrete value, sir, you can only have a certain amount of size. You can't have it don't continue go all the way up, so it'll go be like odd. I'm not sure.
All right, thanks much, Ms. Clark. Although I never asked about the discrete one, but thanks for extending yourself. Ms. Wilson, explain the continuous variable for us.
Sir, just like Miss Clark, I don't know how to explain myself, sir.
Campbell, explain the continuous variable for us.
So I guess the continuous variable would have been more permanent, sir, or constant.
Sound like you understand what continuous variable is, Mr. Campbell. Mr. McLean, McLeod. That's pronounce the name properly. Mr. Ojeno,
Yes, sir.
you can explain to us what you understand by continuous.
Continuous variable that calls a set of values or a set of infinite values. You say can always go up, stuff.
Yes, so it's a set of infinite values between two values. So you can have measurement between two values infinitely. All right. So it means that if you're measuring between two whole numbers, you can take any size fraction between the two whole numbers. It is infinite in terms of how much you can cut up that space between the two whole numbers. So in terms of fraction, you can get up to as small as you can get 1/64, 1/34. No matter how small the fraction, you can get measurement between it continuously. That's why it is called continuous variable. So you can continue, let's say the value is between 6 and 7, and you're looking at the either the decimal value between the whole number 6 and 7, or the fractional value between the whole number 6 and 7. You can get infinitely many fractions between 6 and 7, right from 6 to 7. So those values are continuous in terms of you can take values of any reading between them, infinite many reading between those. Now, as opposed to discrete values have specific values that you are only allowed to read. You're not allowed to read, in the case of a shoe size, you're not allowed to have values such as 5 3/4. But we don't have 5 3/4 shoe size. So the discrete values are a certain specified set of values that can be used to measure in those particular circumstances. Is that clear now, guys? The difference? Is it clear to you now, Mr. Campbell?
Yes, sir.
All right. Mr. Paisley, are you understanding anything from what I've just said?
Yes, sir.
All right. Mr. Giovanni, are you understanding anything at all? Javon? All right. Moving on, guys. We are going to be looking at histogram. And remember from the previous class when we were looking at the different types of charts that we can use to represent our data, histogram was among those. Now we kind of reserve the histogram a little bit because it is a whole topic by itself, because there are so many things involved in that histogram that we need to talk about. All right. So first we are going to talk about what the histogram is. So it's a bar graph representing a frequency distribution of a quantitative variable. A histogram is made up of the following components. So it's a what? Bar graph. Now, the thing about the histogram, it can be unlike the simple bar chart where you would maintain a specific width for all of the bars. So for simple bar chart, you generally keep all the bars of the same width. But for a histogram, there is a little bit of flexibility for histogram. You can either keep the bars at the same width, or you can have them at different widths, depending on what you're using to represent the frequency. All right. In the simple bar chart, the height of the bars, because they're all of the same width, the height of the bars tell you the frequencies. Right? So when the bars are of the same width, we usually just measure the height against the y-axis. And whatever value we get from the y-axis based on their height, that gives us the what? The frequency. For the histogram, however, we can do the same thing for the histogram by using the height of the bar, but in some cases, we can also use the area of the histogram to represent the frequency, the area of that bar graph to represent the frequency. So for the histogram, it have that versatility. So the various components of the histogram, it has a title which identifies the population of interest. It's a vertical, you have a vertical scale which identifies the frequency in the various classes. There's a horizontal scale which identifies the variable x, the value for the class boundaries of the class midpoint or the class midpoint may be labeled along the x-axis. So we use whichever method of labeling the axis best presents the variables. So all it is saying, the frequency for a histogram is always measured on the vertical axis. As in the case where we are using the height of the bar to measure the frequency, we measure it against the vertical axis. And the horizontal axis, which is the x-axis, is labeled either with the boundary values, the same boundary values that we have been discussing just now, or we label it with the class midpoints. So depending on which of these best give you the representation of the variables. And so this is the conventional way in which we would label our histogram. All right, so note, the relative frequency is sometimes used on the vertical scale. It is possible to create a histogram based on class midpoints. All right, here we have a histogram, a graph in which the classes are marked on the horizontal axis. So the classes are marked on the horizontal axis. And the class frequency